I didn't like it because it was all about formulas. It was memorizing, and I hate memorizing formulas and remembering which one is which and how to do whatever, and it's very frustrating. So the first lesson, and I know that some of y'all aren't at the place that you're Unit 3 just yet, so just you're approaching it from, this is a preview, this is what's to come, and take thing. All right, so conic sections from the recording, those of you who got the recording to work, realize and heard that the conic sections are just an intersection of a double-naped cone, and now you're going to see why I wanted you to watch that recording. The plane. If the plane intersects straight across, you get a circle. And in the recording, they showed you those intersections. Those of you who got that to work, was that kind of an interesting way to be able to see that? If it's want me to do, if it's intersected like that through the bottom, it's a parabola. And if it's intersected, we'll do this one in purple, straight down through the two edges of the double-naped cone. One at a time. But where they come from is the intersection of a plane and a double-naped cone. And so if you didn't get to watch the recording, I think that you should do that. Don't do it right now. You're looking at the picture in the book and on the Teachlet, because they're much more professionally done and a lot easier to see. My terrible kind of messed up picture, I knew would not explain it. The students would look at that and go, have you trying to determine which kind of conic section you're working with based on, there it goes. Can you see what I was drawing on? Yeah, okay, I got the right thing up. Based x plus dy plus e equals 0. Now, that doesn't mean anything to you at this point except that the same as b. Then it's a circle. Okay, so when you're looking at the equations, all you're doing is isolating the squared terms. The rest of give you and result in a circle. So all you got to do is look at it. Look at it. If the x squared and the y squared are on the same side and they have the same number as a coefficient, it's a circle. Operating. I'm having all kinds of techno issues, and I keep writing in red. I think that's part of my problem. Red is not a good color for me. It makes me feel very anxious. If A is not, then it's an ellipse. Okay? That's okay. I knew you were kicked out. So technically it should be the absolute value of the same number, but the same sign. It's an ellipse. If the A, all right, if in other words, if there's only an x squared or only a y squared, it's a parabola. It's only going to be a parabola if one of the squared terms does not exist. Let's do it. I hate red. Why do I keep writing in red? Green, purple, brown. Let's do blue. The last one is a hyperbola. Hyperbola. And that's how you're going to tell. It does have two square terms, but the signs are going to be different. Oh, that's true. I can do that. That's not off topic, Taylor. It's just something that I forget. That's a very good. Okay. So if all you're doing is saying, what kind of conic section is this? That is pretty easy. Because if you know these four things, A equals to B, it's a circle. Class, I think your class is at noon. Let me double check. Yeah, you're at noon. This is the Algebra 2B class. Oh, she already left. Did she leave? Yeah, I think she left. Okay. Or 0, it's a parabola. And if the signs of the squared terms are opposite, then it's a hyperbola. And then we're going to talk about, once you know this and you can identify which kind of conic it is, the rest of it. Problems in 3-1. I'm just pulling one right out of the book, and so we can look at, all right, right here, graph the equation. They want you to do a T-chart, don't they? Ugh. All right. When you have to graph these in the first unit, they want you to do a T-chart. And you, I'm sorry, that was a very not show you how we're going to determine what kind of conic are, because to me, if you know what it is, it's going to be easier to graph it. I'm just a little bit rebellious, and I like what I like, and I don't like what I don't like. So, it's kind of like can do a T-chart. I know, because I'm like a little rebellious. I can't help it. I just am. So, for instance, 25x squared plus 16y squared but it's supposed to be an X. It's because my handwriting is so bad and my mouse pen's not cooperating today. So what we're looking at is the X squared coefficient and the Y squared coefficient. It's an ellipse. And you can do a T-chart and plot some points and get where the ellipse is. But I'm going to show you when we do the unit on ellipses, that so that you can get the idea of what shape it is. But my thing is, if all you need to know is that it's an ellipse, that's easy. Compare the A and the B, and then you can determine that. Minus 4. What's that going to be? Look at your A and your B. Now, you may not even know what a hyperbola is because you didn't get the recording to work, and that's okay. All right, let's see. What else we got? Hyperbola, circle, hyperbola, hyperbola. Okay, we got a parabola, a hyperbola, a circle. I think the majority, right, it's a hyperbola. Yeah, and the minus is like plus a negative, right? So you know that that 40 is actually a negative. Yep, that's, didn't mean to trick, but that is. Let's say 11x minus 2y plus 6. I know that doesn't look like any parabola you've ever seen, but guess what? That is a parabola because there is only a y squared term. There's no x squared. Looks like this. It's a sideways parabola. And you've not done sideways parabolas before. So that's going to be new. In this first unit, all you're doing is just some. The thing, we're adding some information. Oh, sideways parabolas are fabulous. You just don't understand them yet, Jamison. Wait till you understand them, and then you'll be like, oh, psh, they're fabulous. Information is how to tell what kind of conic it is, and do a t-chart and get a rough idea of the graph. But let's talk about parabolas specifically. What time is it? Okay. You've worked with all the quadratic stuff you've done before are parabolas. But we're going to add a little element of where they come from. So let's say for or not. I don't. I just want a general parabola. All right, so if we have a parabola that's in this shape, you know what a vertex is. These that you've not seen before. There's a line down here called a directrix. D-I-R-E. Okay, the focus point. It's all about the picture and the relationship of the focus and the vertex and the directrix. Okay, and let me show you why. You know the HK is the left and right and the up and down move from the parent. Vertex is, we'll call it C. It's just a length. Yes, and from the focus, from the vertex to the directrix is also absolutely. Now, remember I showed you I told you a minute ago, you can have sideways parabolas. You can. They can look like this. So what direction do you think the directrix is going to be on a yeah, it's going to be vertical. It's going to be this direction. So the directrix here goes up and down. And the focus is still on the inside, and it still aligns with the vertex. Sideways parabolas have the y as the squared term, and the up and down parabolas have the x as the squared term. If the x is squared, you know it's up or down parabola, right? Everybody's kind of like, okay, I can kind of get that. Now this one is going to have a positive parabola opens downward, which means the directrix is still horizontal, but it's above it, right? The focus is on the distance c here, and you still have this as a distance c here, except for this one, there's going to be a negative number in front of the x squared because it went down. So it's going to be negative something x squared. And all those things will be the same. See, even when it doesn't tell you to graph a picture, if you sketch a little picture, it's going to be easier. So what's going to happen with the y squared for this guy down in the bottom? Yep, they are. Okay, so let's just box them off, right? So you got 4 different situations, and you can remember the 4 different formulas if you want to, but if you like page 626. I will not be using the formulas because I can't remember them all and I get them backwards. I'm going to draw a picture. On time, I promise. I'll let you process. Kind of finish your notes. Yeah, and if you've looked and you want to see them, they're on page 262 of your book. I'm not going to use them. I mean, I'm going to use parts of them, and I'll show you in just a second what I'll use. But if you want to see them all broken down and all their different various parts and pieces, that's where they are. You're going to like my way better, I promise. I've had a few students that liked the formulas better. All right, I'm going to go to the next page. Is everybody okay? Anybody want me to wait just a second longer? Just holler when you're ready, Javante. Okay. Got it. Okay, cool. Nobody else said they needed me to wait. So let me go to the next thing and kind of show you what you are before. You've seen this before. Y equals, this is the one part you probably have not seen. And we're going to find that with this C value here. All right, and then we've got x minus h squared. You've seen that before. And you've got plus k. You've seen that before. 1 over 4c times y minus h, oh, sorry, y minus k, plus h. All right, now, this should feel very comfortable. Inside the parentheses on the now see the y is what is squared. That should be squared. Oh my goodness gracious. This should be squared, not to the k. A squared power, it's a parabola. There we go. Okay, there we go. All right, so this one over here of c down, if you've got a negative, well, let's call it a negative 1 over 4c. And let's call that 1 over 4c positive. Positive 1 over 4c. And it's going to be to the left if you have a negative 1 over 4c. All right, so those are the things you kind of have to know. And then the thing that I always made a mistake about the x and the y and the h and the k. Y and k always go together, right? X and h always go together. So when h plus k, it's y minus k plus h. Do you see the difference in that? And I know it may seem like, what's it matter? It matters a lot. These are the standard equations for parabolas that open up and down or left and right. Do you see the difference that these are the left and right because the y is squared? And then we'll graph one. Let me find one to graph. Oh, I'm gonna run out of time. I'm not gonna run out of time. I'm good. All right, let's do this. We're going to write an equation of the parabola. I don't like the way they approach this. Hold on a second. I got to find a problem I like. It's parabola. It's just a sideways parabola with little arrows. Yes, Javante. The y minus is from the formula. Just like what you're used to seeing. Okay, cool. Good question. Do we minus k? Okay, I think you asked that up in the Q&A pod too. Next, ooh. And I'm just doing one in the book. Negative 5, 4 and a focus of, oh, that's so easy. All right, that's okay. We'll do it. You don't have to sketch a graph, but I'm telling you, if you sketch a graph, this is going to be easier. So let's sketch a graph. And I'm always going to sketch a graph because otherwise I'm going to get it backwards. It's at -5, 4. So we're going to call this -5. We're going to call this 4, and here's my vertex right there. My focus. Second, we're almost there. Which way is this going to open? Up, down, left, or right? If this is the vertex and this is the focus. Everybody's typing. See who types fastest. Well, if it goes up, is the focus in the right spot? Mm-mm. If it goes to the right, is the focus in the right spot? Mm-mm. There you go. It's got or a y-squared formula. Do you see how that works? The focus is always on the inside. If they gave you the directrix, that would tell you which way it opens. Now, the C is the distance from the vertex to the focus or from the directrix to the vertex. So C. So if they gave us our directrix, we could do that. I don't think, yeah, it's going to be 4. Because if this order pairs at something 4, then all the way down to here, this distance is. What is the H and what is the K? Once you know the C, the H, and the K, you can write the equation. And all you had to do was sketch a little picture. One over 4 times C, well, C is 4. They happen to be the same. It's not always the case. X minus H, well, H is -5 squared plus K. I don't know how you could do this on a graphing calculator given what you're given, because these were the two pieces you were given. It was write the equation given this. I don't know how a graphing calculator is going to help you with that. So now we got to simplify it, of course. So it's 1 over 16 times x plus 5 squared plus 4. You just have to remember C is two different things. It's the distance from the focus to the vertex or the distance from the vertex to the directrix. Sketch a little picture. I had you, when I taught geometry, please draw a picture, mark your picture up. They would not do it. The students that would draw their picture and would mark their picture up could usually figure it out. No big deal. So the picture really, really helps a lot. You like my sideways? Okay. But you have to know those two different formats. Okay, so there is some formulas that you have to know, but all those other ones that they listed, you don't need all those. Unless you like formulas. They work. It's not that they don't work. They do work. Tell me if you need me to just hold off a second before I clear the screen, and I'll wait just a minute. See, and I love conics because there's an easy way to approach it that the books don't teach. And the students give me a red X if you need me to wait. How about that? Let's just do it that way real quick. No red X's? All right, that means we're good. Okay. All right, now let me show you. Now this was, oh, just a second. But the equation we're going to start with is not in vertex form. I think surely they give us something like that. Yeah, they do. And we've got to find all the pieces and parts. And of course they don't give us any sideways ones like I want. Oh, wait, nope. Well, let me flip back here. Let me see right here. Oh, here's one. Okay. We'll do this one. Right, and then Miss Long asks you to type something, and oh, it's okay. Last year I was teaching a different school, not this school. I taught a class, and they aren't really words at all, but they all knew what I was talking about, so it was kind of like we had our own language. It was hilarious. All right, so here's the problem: y squared minus 8y, and I'm not offended at all, so don't even worry about it, plus 8 out your formula. That's the vertex form is 1 over 4c times y minus k squared plus h. That's what I want it to look like. It doesn't look like that, but I got to do some, oh, not y equals x equals. Because, see, the y is the thing that's squared. So I know this is going to be a sideways parabola. So what I'm going to do on the y. All right, how in the world is she going to do that? Here's what I'm going to do. I'm going to put the x term on the side by itself, because that's what my formula has, and I'm going to put that over here, but I'm going to hold off on that. Hold on, let me equals negative 8x minus 16. That part shouldn't be too hard. Everybody should be okay with that. Now what I'm going to do is I'm going to complete the square. Remember the so negative 8 squared is 4. 4 squared is 16. That was my special, lovely, wonderful number that I added to both sides. Remember doing that process? It might have been a while ago. So we're going to add 16 to this side, which means we have to add 16 to this side. All right, questions about that step? Then this is now a perfect square. I can write it as x minus 4 squared equals negative 8x, and then add these together. They equal 0 for this one because it's a simple example problem, but they don't always equal 0. If they didn't equal 0, then we would just put it to the other side. Okay. I know this may seem strange as 1/8 because I want it to look like my standard form. And my standard form doesn't have anything divided by everything. It's got a coefficient. So I rewrote that divided by 8 as a fraction of negative 1/8. Now, isn't this? Here. Okay, so we need to find the vertex. We need to find the length of C. We need to know which way this thing opens. Which way does it open? We can know that right here. Right? And we know that, oh wait, I dropped a, this is a Y. I was like, wait, that's supposed to be a Y. Yeah, all right. I was trying to hurry. So since this is a Y, we know it goes left or right. And since this is a negative, which way? It's going to open this way. It's going to open toward the left. It opens that direction. All right, that being the case, we got an idea. We know we have a plus 0 here, so our vertex is 0, 4 is our HK. Remember, the Y and the K go together. This is so much information very fast. Since this is Y, this is the K value, not the H value. At 0, 4, we'll call that 4. We know the graph goes this direction. Now what is C? If we have 1/8 equals 1 over 4C, what's the distance of the vertex to the directrix? What's that got to be? Don't make it that hard. What times 4 equals 8? There you go, 2. 2 times 4 equals 8. So I know I have a directrix right here. 4. I didn't have to do anything but just count, because the distance from here to here has to be 2, and the distance from here to here has to be 2. I mean, that kind of looks weird right there. So this is 4 units. Okay. So that was very fast little sketch, but there's our focus, there's our directrix, there's our vertex, and we completed the square to find it. A lot of stuff. You have to practice. But if you'll just draw a little picture first, it does make your life easier to know kind of what you're looking at. And that was a lot. I know y'all are writing it down. A lot to remember. And remember, when the Y is squared, that number inside the parentheses is the K, not the H. That's the hardest thing. I would always get that backwards as a student, because it's always X minus more. I think, let's see, I can tell you what our live lesson schedule is going to be. I actually have the schedule posted on the message board so you can know what we're talking about when. Let me look at what I have here for you guys. Oh, Taylor's gotten out. No, she's trying to get back in. Hold on, let's let her in. There we go. Let her back in. Let's see, today is the 12th. So we don't have, on the 19th, I'm going to talk about ellipses and, no, I'm going to talk about circles. Oh, the domain. Sure, we need to talk about that. Yes, it's recorded and I will definitely post it. Yes. Okay. Yes. Let's talk about the domain. I'm so glad you brought that up. Think about the domain or the x values. Once you get a graph, the domain is easy. What's the smallest x value for our picture? Is right here at 0, right? So our domain, our x, is less than or equal to 0. lengthways parabolas have a range of all reals, and all up and down parabolas have a domain of all reals. The domain are the x, and the range are the y. That's correct. I know this is a lot of information in a very short amount of time. Definitely. And I'm actually going to, if you look at the schedule, when I'm working with the Algebra 2B Foundation students, they're a little bit behind. So if you're working on parabolas and you know that in the B semester, in the B class, I'm working on parabolas with them, I don't mind you sitting in. Just remind me that you're here, you know, that you mean to be here. And you can see on the schedule when I'm going to, they're getting close to about a week behind y'all. Except the pre-calculus one is all messed up because anyway. All right. So deep breath, and know when you're reading through the online lesson, it's good to get that perspective. But remember, there's a way that you can look at the picture and see how everything is related. So if you stress out with trying to so that you get comfortable with what we talked about today, so when we talk again next week, we're going to work on ellipses and circles. And I'm going to give you similar kinds of tips and things to remember. And if you don't have this down, then it's just going to pile up. So make sure you get this practice in. If you're turning in your notes and your work to me, do it daily. Do it lesson by lesson if you don't mind, because then if you've got questions or anything on there I need to look at or let you know to kind of look at, then I can do that day by day. That would be great. And if you don't have a clue of what I just talked about, it has nothing to do with you. There's some students that I'm having them turn. So much they make me happy. I don't want to not do conic sections. Well, the next group is doing logs. I love those too, so that's good. All right, y'all. Have a good afternoon. Thank you so much for coming. Conic sections is the main topic, and we talked about parabolas and just an introduction. All right, bye, y'all. Javante, did you need anything else? Tiffany, did you need anything else? Sometimes students forget to leave. There she goes. Javante, did you need anything?